Find the Fourier transform of e to the power of minus absolute x and evaluate the value of integral of cos x by 1 plus s square ds from 0 to infinity. Here, first, to find the Fourier transform of e to the power of minus absolute x, we convert it as a function of s, that is f of s is equal to f of, in flower brackets, e to the power of minus absolute x, close flower brackets. This is equal to, as we know, 1 by square root of 2 pi integral minus infinity to infinity e to the power of isx into e to the power of minus absolute x dx. Here what happens is we are doing the Fourier transform. Later, by using inverse Fourier transform, we will simplify further. So, which is equal to, this equation further is equal to minus 1 by square root of 2 pi integral minus infinity to infinity cos sx plus I sin sx into e to the power of minus absolute x dx. Here we know the expansion of e to the power of isx can also be written as cos sx plus I sin sx. Therefore, when we multiply this particular equation term with this, we get cos sx into e to the power of minus absolute x. Once we get that, the equation splits into two parts, that is, two terms are formed. Here the equation becomes 1 divided by square root of 2 pi integral minus infinity to infinity cos sx e to the power of minus absolute x dx plus I divided by square root of 2 pi integral minus integral to integral, that is minus infinity to infinity sin sx into e to the power of minus absolute x dx. Clearly, absolute x is equal to x. That is, when we say absolute, it does not take the negative sign. It is only the value that the particular variable is given. So, even if it is minus 2, it becomes 2. If it is plus 2 also, it remains 2. If it is minus 3, it will be considered as 3. That is, absolute of minus 3 is 3. Absolute of plus 3 is also 3. Therefore, clearly absolute of x is also x. When x is greater than 0 and less than infinity, integrand in the first integral, that is, the first integral is a even function, and the integrand in the second integral is an odd function, right? With this combination, it becomes an odd function. So integral of an odd function is 0. Therefore, 0. Now, here this equation can also be written as 2 divided by square root of 2 pi, because we have applied this from minus infinity to infinity. Now it becomes from 0 to infinity because this is the limit now. So for a positive integral, it is, that is the even function integral, only the even part of the integral sign is taken. Therefore, we have this equation and this gets converted to 0 to infinity, and here multiplied by 2. So 2 divided by square root of 2 pi into integral from 0 to infinity cos sx into e to the power of x dx plus 0, which is equal to 1 by square root of 2 pi into, once we simplify this, we will get e to the power of x, e to the power of minus x divided by 1 plus s square, that is the s here, 1 plus s square into minus cos x sx plus s sin sx. and the integral is from 0 to infinity. That is, a value of 0 to infinity is applied to this particular term. Therefore, we get square root of 2 by pi into 1 by 1 plus s square into 0 minus, in brackets, minus 1. So this becomes, the value becomes 1. 1 minus into minus becomes plus. So it becomes 1. So the value is retained. So square root of 2 by pi into 1 by 1 plus sx square. Next we find out by inverse Fourier transform fx, function of x, is equal to 1 by square root of 2 pi integral from minus infinity to plus infinity f of x into e to the power of minus isx dx. Here, therefore we find out that e to the power of absolute minus absolute x is equal to 1 by square root of 2 pi integral minus infinity to infinity square root of 2 by pi into 1 by 1 plus sx square into cos sx minus I sin sx dx. That is, we have replaced this particular function with this value. So hence the equation becomes, once we simplify both the equations, one equation with cos sx, one equation with sin sx. So 1 by pi into integral 0 to infinity cos sx by 1 plus x square into ds minus I by pi integral minus infinity to infinity sin sx by 1 plus s square ds. Herein, what happens is, the integrand in the first integral, as we know, is even, whereas in the second integral is an odd function. So this part of it is, this part of the terminology becomes 0. Therefore we consider only the first part. Once we consider the first part, e to the power of minus absolute x is equal to 2 by pi integral 0 to infinity cos sx divided by 1 plus x square dx. Here we simplify it further by putting from the right hand side to the left hand side, the pi is shifted and then 2 is shifted to the LHS again. So the equation becomes, pi e to the power of minus absolute x divided by 2 is equal to the remaining part of the terminology, that is remaining part of the term, that is 0 to infinity cos sx by 1 plus sx square dx. Hence proved.